So we have an open box made out of a 3 by 8 foot rectangular piece of metal by cutting out squares of equal size from the four corners. So we'll begin by drawing the box. And we'll say that this begins at 8 feet by 3 feet. However, we're going to cut out some squares from the sides. We don't know how much that is, so we'll call those x. So that we can say that after we cut the squares out, this distance is going to be 3 minus an x on the bottom and minus another x on top, so it is 3 minus 2x. And so this side is also 3 minus 2x, and this side on the bottom is going to be 8 minus 2x. All right? We'll call this the length, and we'll call this the width. So you start at 8 by 3, but we're going to cut a little bit out of the width, cut a little bit out of the length. We'll call that the part we cut out, we will call 2x. But then they ask us for the maximum volume. Now, in order to find the maximum volume, number one, we have to write a function for volume. All right. And then after we write the function for the volume, we take the derivative. And then after that, we find the critical points and see which one of those critical points gives us the maximum. All right, so let's first write a function for volume. Volume is equal to length times width times height when we have a rectangle like this. Now the length we have is 8 minus 2x. The width we also have 3 minus 2x. Now the height is a little hard to see, but use your imagination a little bit. If we've cut out squares that are x by x and then we fold the pieces upward along this dotted line, we can say that the height is just that x. If we imagine that this little rectangle we have here is folded upward into a flap that forms part of the box. So our volume is 8 minus 2x, 3 minus 2x times x. Now, taking the derivative while it's in this form may be a little bit difficult, so it might be a good idea to simplify this slightly by using the FOIL method. When we use the FOIL method, we'll do 8 times 3 for 24, 8 times negative 2x for negative 16x, negative 2x times 3 for negative 6x, and then negative 2x times negative 2x would give us positive 4x squared. So with this expression we just FOILed, all of that's going to be times x. So now let's go ahead and multiply x through all of that. If we do that, we'll have 24x minus 16x squared minus 6x squared plus 4x to the third. And we can simplify this just a bit further by combining the x squared terms. So we'll have 24x minus 22x squared plus 4x to the third. This is going to be our volume function, and we can carry that forward to the next slide so that we can take the derivative. Here's our volume function on our new slide, and we will take the derivative. So when we take the derivative of 24x, we reduce the power by 1, giving us 24. We have second power, we'll bring that down, and that will give us negative 2 times 22x to the first. We reduce the power by 1, bring the 2 down. And then for our last term, we bring the 3 down, giving us 3 times 4 x. Now it's no longer third power, we'll have second power. And when we simplify, we'll have 24 minus 44x plus 12x squared. And this is going to be our v prime. Now, what we need to do is find the critical points. And to find the critical points, we set this equal to 0. You might recognize there's something we can divide everything by. Now, if you can divide everything by something to make your math easier, I recommend it. In this case, we can try dividing everything by 4 to make our numbers a little easier to work with. If we divide everything by 4, including the 0, we'll have 6 minus 11x plus 3x squared is equal to 0, because 0 divided by 4 will give us 0 again. Now what we have to do is think about if this is factorable, or we would be maybe better off using a calculator here. Let me rewrite this in order. 3x squared minus 11x plus 6. You can try the AC method. Now the AC method doesn't work all the time. But let's take 3 times 6 and see if there's any way we can make this work and give us 18. If we just do 3 plus 6, that gives us 9. That's not a match for the middle term. But we could try 2 plus 9. Because 2 times 9 does give 18, and 2 plus 9 does give 11. It's the right number, but the wrong sign. So, negative 2 and negative 9 would give the negative 11. That is a match, so we split the negative 11 into negative 2 and negative 9. So when we rewrite this, we'll have 3x squared minus 2x minus 9x plus 6 equals 0. Well, in the AC method, we don't factor everything all at once. We factor it 2 at a time. So we look to the first two terms, and we look at what they have in common. The only thing they have in common is x, though. So we pull the x to the outside. We look at what's left. If we take one of the x's out of here, we would have 3x minus 2. Then we look to the second pair. Well, I don't see any x they have in common, but they do have a 3 in common. And since the first number is negative, we can say they have negative 3 in common. So we take the minus 3 out, and we'll see that we can pull negative 3 out of negative 9, and we'll have 3x. And then 6 divided by negative 3 gives negative 2. So let's repackage the x and the 3 into their own parentheses. And make sure to include the minus as well. So our first set of parentheses will have x minus 3. And our second set of parentheses will have 3x minus 2 equals 0. What we can do is now solve each piece and set it equal to 0. So we have x minus 3 equals 0 and 3x minus 2 equals 0. If we solve the first piece, we get x equals 3. And if we solve the second piece, we'll begin by moving over the 2, giving us 3x equals 2, and x equals 2/3. X equals 3 is our first answer, and x equals 2/3 is our second answer. Now, one of these answers is a fake answer. Here's the reason why. In our original shape, before we cut anything out, we were 3 by 8. So it's not possible to cut out 3. If all you started with was 3, then you'd have no shape at all. So x equals 3 is not possible. This is a fake answer. So our correct x is x equals 2/3. So if we want to actually find the volume, we can plug x equals 2/3 into this equation that we found earlier to actually get the max volume. So we'll need to go to a calculator and say volume is equal to 24 times 2/3 minus 22 times 2/3 squared plus 4 times 2/3 to the third power, and we get 7.407. Well, all right. That takes care of that problem. We now know how much to cut out, 2/3, to get the max volume, and we found the volume itself is 7.407. So in this problem, we were asked to find the limit as x goes to 5 of x minus 5 over square root of x plus 4 minus 3. Now, when you are trying to use L'Hopital's rule, we are looking for one of two scenarios. If you get 0 over 0 or infinity over infinity when you plug in the 5, if you get 0 over 0 or infinity over infinity, that means you can use L'Hopital's rule. So let's see if this one is L'Hopital's rule worthy. So if we do let x equal 5, we'd have 5 minus 5 on top and root of 5 plus 4 minus 3 on the bottom. On the top, we definitely have 0, because that's 5 minus 5. On the bottom, root of 5 plus 4 is root 9 minus 3. Well, that's 3 minus 3, and that's going to give us 0 over 0. What that means is we are okay for L'Hopital's rule. So now we can take the derivative of the top and the bottom. So we're going to take x minus 5, get the derivative, over root of x plus 4 minus 3, and get that derivative as well. Well, if we take the derivative of x minus 5, derivative of x is just 1. And the derivative of minus 5 is 0. So we have just 1 on the top. Now the derivative on the bottom looks a little nastier because of the root, but we can just rewrite that as x plus 4 to the 1/2. When we take the derivative of something to the 1/2, we get 1/2 of that same thing raised to 1/2 minus 1. Now 1/2 minus 1, it turns out, is negative 1/2. That's our new power. Then we say times the derivative of what's on the inside. The derivative of x is just 1, and the derivative of 4 is just 0. So all that's just going to be times 1. So when we rewrite this limit, we take the limit as x goes to 5 of 1 over 1/2 of x plus 4 raised negative 1/2. So now, when we plug in 5, we'll have 1 over 1/2 times 5 plus 4 raised to the negative 1/2. So 5 plus 4 gives us 9. We'll have 1 over 1/2 times 9 to the negative 1/2. Now let's come over here and try to simplify that 9 to the negative 1/2. Well, 9 to the 1/2 is just 3. So really that's like saying 3 to the negative first power. But 3 to the negative first power is just 1/3. So we'll have 1 over 1/2 times 1/3. That's the same as saying 1 over 1/6. But 1 over 1 over 6 is a double reciprocal. And so our answer is just 6. So we can say that the limit as x goes to 5 of x minus 5 over root x plus 4 minus 3 is just 6. In this limit, we have x goes to infinity, 3x over e to the 2x. And let's start by just plugging in infinity and see if we get infinity over infinity. So we'll take 3 times infinity over e to the 2 times infinity. So if we take any number times infinity, just gives us infinity. And e raised to infinity definitely gives us infinity. So we'll have infinity over infinity, and this is okay for L'Hopital's rule. We take the derivative of the top over the derivative of the bottom. So the derivative of 3x is just 3, and the derivative of e to the 2x, we need to be careful not to make a mistake on that one. So when you take the derivative of an e function, the exponent stays the same, but you bring the 2 down anyway. So you'll have 2 e to the 2x. So the 2 comes down, but you still have 2x up here. And that's going to be true anytime you have a base of e. So now, if we take the limit as x goes to infinity, we now have 3 on the top and 2 times e to the infinity on the bottom. But, like we said last time, e to infinity still gives infinity. So we'll have 3 over infinity, and any number divided by infinity is 0. So we'll say, in this case, our limit would be 0. Anytime you have any number, no matter how big that number is, and it's divided by infinity, your answer is automatically 0. Don't care how big it is, still 0. A 15-foot ladder is leaning against a house when the base starts to slide away. So let's draw the wall of a house here. And let's say we've got some kind of ladder. And let's say that its length, which I'll call C, is 15 feet. Now it says the base is 12 feet away from the house. So I'll call that B. It's 12 feet. It says the base is moving away in the left direction at a rate of 18 feet per second. Now, the fact that they say rate and it's in feet per second tells us that is the derivative of b. So I'm going to label that dB dt, and we're going to say that's 18 feet per second. Now, what they're asking us is to find the rate at which the top of the ladder is sliding down the wall at that time. So they're asking us to find dA dt for this distance here. Now, one of the problems here is we don't actually know what A is. It would help for us to get that before we go any further. Also, I haven't written down dC dt because that wasn't given. But I will say that if you have a ladder, and that's a rigid object, we can say that the length of the ladder, C, is constant. We shouldn't expect this ladder to stretch or contract in any way. So even though this wasn't said explicitly, we can say, using what we know about ladders, dC dt should be 0. The length should be constant, while the distances for A and B will change because the ladder is sliding away. So if we have B and C, how do we get A? That'll be our first step. Well, if we have a right triangle, much like this one, we can use the Pythagorean theorem. And we can say that c squared is equal to a squared plus b squared. Well, we know that a is unknown. Box that in. So let's move b to the other side. So c squared minus b squared is equal to a squared. We have c is 15, and b is 12. And a is our unknown. 15 squared is 225. 12 squared is 144, equals a squared. Now we would need to subtract these two. So 225 minus 144 is 81, and that's equal to a squared. And if we take the square root of both sides, we'll have a equals 9. So let's add that a equals 9. We found what it is. And now we can move on to step 2. The thing we're trying to find is dA dt, okay? So to find dA dt, we have to now take a derivative of the function we were using. Now our Pythagorean theorem said that c squared is equal to a squared plus b squared, but now we need to solve for a derivative. So let's take the derivative. And let's take it with respect to time. Now the derivative of c squared will be 2c. Now since we're taking derivative with respect to time, we have to put on a dc dt next to it. We'll do the same thing for the other letters, and we'll have 2a times dA dt plus 2b times dB dt. The good news is we know most of these already. We also found that dB dt was 18 feet per second. So let's place what we know into these equations. We know c, we know dc dt, we know a. What we don't know is dA dt. We also have b and dB dt, and let's plug everything in. 2 times 15 times 0 equals 2 times 9 times dA dt plus 2 times b, which was 12, times 18, which was dB dt. Well, 2 times 15 times 0 is just 0. dA dt is our unknown. Let's try simplifying everything else. 2 times 9 would give 18 dA dt. 2 times 12 is 24. 24 times 18, it will give me 432. Now this is all going to equal 0. So let's move the 432 over to the left, and we'll have negative 432 equals 18 dA dt. Now all we have to do is divide by 18. So in your calculator, take negative 432, divide by 18. When you divide, you should get negative 24. And we'll say feet per second. So as the ladder is sliding away, the side on the bottom at the base is getting larger, while this side that's vertical will be getting smaller at negative 24 feet per second. Now for part B of this question, we have to write some sort of formula to find the angle. So here's our angle. We'll have to pick out a trig function that would make this easier to find. What if we just used cosine, for example? We can say that cosine of theta is equal to adjacent over hypotenuse. Well, that's going to be B over C. Now, since they asked specifically for the rate of change in the angle, we are going to have to take a derivative. So the derivative of cosine of theta is going to be negative sine theta times d theta dt. We'll say this equals the derivative of b over c. Now, when we take the derivative of b over c, you might be tempted to use quotient rule, but you can actually get around the quotient rule this time. And the reason why you can do that is because c is a constant, which means you can factor it out. So let's rewrite this as negative sine theta d theta dt is equal to 1 over c times the derivative of b. So you can just factor the c out completely. Since it's on the bottom, we do have to put a 1 over it, and now that's just going to be times the derivative of b. So we'll have negative sine theta d theta dt is equal to 1 over c times db dt. So let's see which of these we know. All right, we can say that sine of theta is equal to opposite over hypotenuse. We can see that since theta is in the lower left, the opposite is a, which is 9, over the hypotenuse, which is 15. So we'll say that sine of theta is known. Now, d theta dt was the objective of the problem, so we don't know that. We also know that c is 15 and dB dt is equal to 18. So let's collect this information and put it on another slide. All right, let's plug in what we know on this new slide. Sine of theta was 9 over 15 times d theta dt, which we don't know. We'll have c is 15, so we'll have 1 over 15 times dB dt. dB dt was 18. So what we can do now at this point, since we have 15 in the denominator, is just multiply everything by 15. Just stick a times 15 over here and a times 15 over here so that the 15s cancel out. This will give us negative 9 d theta dt equals 18. So then when we divide by negative 9, we'll have d theta dt equals negative 18 over 9, which is negative 2 radians per second. And if you want to change that into degrees, you can, but it's not necessary. So that'll give us d theta dt equals negative 2 radians per second.